Hello guys, thank you for watching my video. So the topic I select for this presentation is thermal. There are two reasons why I select this topic. The first one is pretty obvious because this is a topic that we have just learned, and this is the one that I'm more familiar with. And the second one is this is a pretty essential topic for the AP exam, which I will show you in the next slide. So this is a AP exam topic distribution. So where's thermodynamics? So actually it's under reaction topic, which makes up the 35% to 40% of the exam. So that we can say thermal is a really important subtopic to learn. So let's go over some central ideas about thermal. I think basically we have covered 3 delta in this chapter. Delta H, delta S, and delta G. Delta H stands for the change of enthalpy of a reaction, which can be an indicator of whether this reaction is exothermic or endothermic. Positive means endo, and negative means exo. And after we have learned the idea of it, we have learned 4 ways of calculating it. Then we learn delta S, which is a measurement of the change of disorder of a system. When delta S is positive, it means the condition becomes more disorder. After we have the idea of delta H and delta S, we have a quantity called delta G to combine these two quantities together. And this is the indicator of telling us if the reaction can be occurred spontaneously. The formula of it is delta G equals to delta H minus T delta S. And when delta G is negative, the reaction is thermodynamically favored. So let's go over some questions. First is my free response question, which I selected from the 2015 AP exam. Let's read the question together. Aluminum can be recycled from scrap metal by melting the metal to evaporate impurities. So question A. Calculate the amount of heat needed to purify 1 mole of aluminum originally at 298 Kelvin by melting it. The melting point of aluminum is 933 Kelvin. The molar heat capacity is given and the heat of fusion is also given. So I think this question is a really typical thermal question. So let's set up the general formula of solving it. Q total equals to Q heating plus Q fusion. So Q heating equals to MC delta T, which C and delta T was given. However, M was not given, but we can solve it by multiply the mole of aluminum by the molar mass of it to figure it out, which equals to 1 mole times 27 grams per mole, and times 24 heat capacity, and times 635 Kelvin delta T, which we finally get for 11.48 kilojoule. Then we need to calculate our Q fusion with a really easy step. We just multiply 1 mole of aluminum by its heat of fusion, which equals to 10.7 kilojoule per mole, and we get 10.7 kilojoule. Then we can get our final answer by adding these two quantities together, which equals to 422.18 kilojoule. So let's move on to question B. The equation for the overall process of extracting aluminum from Al2O3 is shown below, which requires less energy recycling existing aluminum or extracting aluminum from Al2O3. Justify your answer with a calculation. So with the reaction that was given, we can see the energy used to produce 2 mole of aluminum is 1675 kilojoule. So what about the energy used to produce 1 mole of aluminum? We can just divide the 1675 by 2, and we got 837.5 kilojoule. Because Q melt, which we find in the last question, is smaller than the Q extracting, which we find this question. we can say that recycling existing aluminum requires less energy. So let's move on to my multiple choice question. So MC1, which of the following describes system that cannot be thermodynamically favored? I think this question is like an application of delta G formula. Delta G equals to delta H minus T delta S. And the thermodynamically favored condition for delta G is negative. So it asks for when it was not thermodynamically favored, which means what is the condition of delta H and delta S to let delta G always be positive? Actually, we can think of this question this way, because we know two positive numbers add together will always be positive. So how can we manipulate the formula of delta G in order to make it to be a positive plus a positive? So we can see there's a negative here, so that if we make delta S to be a negative number and delta H is greater than 0, then we can make delta G is greater than 0 to make it thermodynamically unfavored. So we can select answer A for this question. So multiple choice 2. This question is we need to use heat of formation to calculate delta H. So the heat of formation of all the substances was given except O2, which we know is 0. Then we can just use the general formula of solving this kind of questions, which is shown here. Delta H Rx equals to the overall heat of formation of products minus the heat of formation of reactants, which we just punch numbers in, and we add them together and subtract, and then we got negative 1277 kilojoule. Then we will select the answer B. For multiple choice 3, I select Hess's law problem. So how can we manipulate reaction 1 and reaction 2 to get the reaction that we want? The process I do this question is kind of different from the general process of doing it, because I noticed that both of the products of reaction 1 and reaction 2 is 2NO2, and 2NO2 is not present at the final reaction, so that I know 2NO2 must be cancelled. In order to let it be cancelled, I think we need to reverse the direction of one reaction and add them together so that it can be cancelled. So I try to reverse the direction of the first reaction first, and pretty amazingly we just got the answer. So that we see here 2NO2 just cancelled, and the left one is just the ones we want, and the right one is N2O4. But by reversing the direction of the reaction, we need to also be cautious to reverse the sign of delta H. So I reverse the sign of positive to negative, and then we subtract, we just add them together, so that I get negative 171.07 kilojoule, which we will select answer C for this question. So conclusion, in this video I have covered calculating delta H using Hess's law and energy of formation, calorimetry, calculation and the application of the formula of delta G. For the rest of thermal branches, especially calculating delta H using calorimeter, additional practice are suggested to make sure you guys don't forget them. So thank you guys for watching my video, and have a nice rest of the day.